All right, last example, we are going to compare two exponential functions. So a museum purchased a painting and a sculpture. So here's their painting, here's their sculpture, in the same year. Their changing values are modeled as shown. So the sculpture has a model right here for how its value is changing. So we actually have a function. And then the painting, all we have is the graph of a function to represent the change of the value. Find the average rate of change. We've been doing that. We know how to do this. Find the average rate of change of the value of each artwork over the 5-year period. Which artwork's value is increasing more quickly? Okay, well, why don't we start with the sculpture since that's on the left. So the sculpture has a function of f of x equals 50 times 1.075 raised to the x power, and it says this is in thousands of dollars in x years. So what this 50 tells us, that it starts out at $50,000. Because our value here is bigger than 1, it is increasing, and then x is representing number of years. So what we're asked to figure out is the average rate of change. So we're going to find the slope, which means we need two ordered pairs over the 5-year period. So we're going to go from year 0 to year 5. So from when x equals 0 to when x equals 5. Well, when x equals 0, we don't know the value of the function, so why don't we plug it in? F of 0 is 50 times 1.075 raised to the 0 power. That is just 50. So that ordered pair is 0, 50. Now, when x equals 5, let's see the value of our sculpture here. So f of 5 equals 50 times 1.075 raised to the 5th power. This is about equal to, we'll do a little bit of rounding, 71.78. So that ordered pair, the x was a 5, we got back a 71.78. Okay, so now we're going to find slope between those 2 points. Slope is our average rate of change. So we're going to take our y2, 71.78, minus our y1, 50, all over our x2 minus our x1. This is going to get us a 21.78 divided by 5. And when we divide that out, we get 4.356. What that means is that the sculpture value increased at an average rate of $4,356 per year. All right, so there it is typed in, so it's easy for you guys to see. So go ahead and write that in. We'll move on to the painting. What's nice about the painting is we already have two ordered pairs from our function. We've got the ordered pair 0, 40. Actually, let me just organize my work. We're going to find the average rate of change of the painting over this 5-year period. When x is 0, our painting has a value of $40,000. And then when x is 5, the painting has a value of $64.4 thousand. So that is our two ordered pairs. Let's find slope. So average rate of change of slope is equal to 64.4 minus 40, y2 minus y1, over x2 minus x1. When we subtract that, we get 24.4 over 5, which equals 4.88. So what that means is that the painting value increased at an average rate of $4,880 per year. So there is that one written out. And then the question is, which artwork's value is increasing more quickly? So this one is increasing by about $4,300 per year. This one is increasing by about $4,800 per year. So this is the one that is increasing more quickly to answer that question?